Hello everyone, good evening. So the previous class we have discussed about limits, right, and indeterminate forms. In the last class we have seen indeterminate form 0 by 0 and then infinity by infinity, and then I have given you exercise to do in your own, like 0 into infinity and infinity minus infinity. Those two forms are same as if you take LCM, you will end up with 0 by 0 or infinity by infinity form. So we're going to see the last form. We're going to see the last form. After seeing that form, I'll be teaching you one more new concept in limits, where the limiting value is given, unknowns we need to find, right? That also we will do in today's class. So I'll try to finish as soon as possible so that you will have time to practice more. Okay, so this is session 2 of calculus. So we will start this. So I hope everyone is doing whatever I'm saying, right? So I hope everyone have finished that indeterminate form. So if not, try to complete within tomorrow. Okay. Okay. This is session number 2. So I'll do some 5, 6 problems, then you can do in your own. All problems are very easy. Just only thing is you have to know how to differentiate a function. The forms, the forms 0 power 0, 0 power 0, 1 power infinity, infinity power 0. So whenever you apply the limits, when if it is of the form 0 power 0 or infinity 1 power infinity or infinity power 0, you have to follow one technique, which is very simple, right? Okay, we'll straight away get into the problems. Fine. So limit x tending to 0, 1 plus x whole power 1 by x. Now what happens when you put x is equal to 0? When x is 0, you can see it is 1 plus 0. So 1 plus 0 is 1. 1 by 0 will tend to infinity, right? Always remember, 1 by 0 will tend to infinity. 1 by infinity will tend to 0. So this will tend to 1 for infinity, right? So it comes under this form. If it is 0 by 0 or infinity by infinity, you just differentiate numerator and denominator and try to apply standard formulas whenever it is possible, right? Okay. Now, if it is of the form 1 for infinity, right, what we'll do is, let us call this limit to be equal to y, right? Y is the limit of this function. Limit x tending to 0, 1 plus x whole power 1 by x. You take log on both sides. So log y is equal to limit x tending to 0 log of 1 plus x whole power 1 by x. Now by property of logarithms, log of a power n is same as n times log a. I can bring this power to the first, right? So this I can write this as limit x tending to 0, 1 by x of log 1 plus x. This step is clear. Log a power n. So it is n log e. Now we have limit x tending to 0, log of 1 plus x by x. I can directly write this as 1. I don't even need to differentiate this. Why? Because it is of the form limit x tending to a log of 1 plus f of x by f of x. It is equal to 1, right? Or else you can differentiate this also, but that is not at all required. When apply the limit will be equal to 1. Remember, we need to find y. Y is our required limit. But now we have found log y. From this, you take e on both sides, right? You raise e on both sides. So e power log y is equal to 1. You note that e power log f of x is same as f of x. So e power log of something is same as something. So this will become y is equal to e. So y is equal to e is the required limit for this function, right? Yes. So we'll move on to the next problem. So the next problem is problem number 2. Limit x tending to 0, cos x whole power cot square x. Okay, cot square x, I think. Yes. Cos x whole power cot square x. Now when you apply the limit, cos 0 is 1, cot 0 will tend to infinity, right? Because cot 0 is cos 0 by sin 0. Cos 0 is 1, sin 0 is 0. So 1 by 0, it will tend to infinity. So it is of the form 1 point infinity. Let us call this limit to be equal to y. So y is equal to limit extending to 0, cos x whole power cot square x. You can see after applying log, again it is converted to either 0 by 0 or infinity by infinity form only, right? If you know how to solve infinity by infinity and 0 by 0 form, you can do any forms. Okay, now you take log on both sides. So log y is equal to limit extending to 0, log of cos x whole power cot square x. So log of a power n. So this will become limit extending to 0, cot square x into log of cos x. Now cot square x can be written as, this can be written as limit extending to 0, log of cos x divided by tan square x, right? See, because cot square x is 1 by tan square x. Now what we'll do is we'll apply some standard formulas here because I don't want tan square x in the numerator, so in the denominator. Let us multiply and divide by x square. This will become 1, right? Because we know tan f of x by f of x is equal to 1. So we have limit extending to 0, log of cos x divided by x square. Now it is of the form 0 by 0, right? Because cos 0 is 1, log 1 is 0. Log 1 is 0, log 0 is undefined. So we will have limit extending to 0. What is d by dx of, what is d by dx of log of f of x? It is 1 by f of x into f dash of x. So log cos x is 1 by cos x into derivative of cos x is minus sin x, right? Log of f of x. Your f of x is cos x. So 1 by cos x into d by dx of cos x whole divided by d by dx of x square is 2x. So we have limit extending to 0 minus sin x by cos x into 1 by 2x. Now this sin x by x, this sin x by x, I can write that as 1 because sin f of x is x, that tends to 0 when x is 0. So we are left with limit extending to 0 minus 1 by cos x. So when you apply the limit, cos 0 is 1, this will be minus 1. Remember, we have log y is equal to minus 1. So from log y, if you want y, you take e on both sides. So e power log y is equal to e power minus 1. E power log y is y. So y is equal to e power minus 1 is the required limit for this. Okay, I think I forgot 2, right? You have 2 cos x. Okay, minus 1 by 2. So e power minus 1 by 2 is the required limit for this function. E power minus 1 by 2 is the required limit for this function. Yes. So third is limit extending to pi by 2 sin x whole power tan x. Now when you apply the limit, sin pi by 2 is 1, tan pi by 2, tan pi by 2 is infinity, right? So tan pi by 2 is infinity. Okay. So it will tend to 1 point infinity form. So let us call y to be the required limit. Limit extending to pi by 2 sin x whole power tan x. You take log on both sides. So log y is equal to limit extending to pi by 2 sin log of sin x whole power tan x. So this is limit extending to pi by 2 and we have log of a power n. So it is n log a. So this is tan x into log of sin x, right? Tan x into log of sin x. What form is this? What form is this? I can write tan x as cot x, right? So limit extending to pi by 2. See, here I cannot apply standard formula because you can see where f of x is x. I should not do this. What I should not do this? I should not multiply and divide by x. I cannot make this as 1. Why? Because your x is tending to pi by 2. What is your f of x? F of x is x. x is not tending to 0 when x is tending to pi by 2. So I can't apply standard formula here. Is it clear? Tan f of x by f of x is 1 provided that f of x must tend to 0 as x tends to a. Your f of x is x, right? That is not tending to 0 when x is tending to that. So we will redo this, right? We should not use standard formula, right? Okay. Now I can write this as log of sin x whole divided by cot x, right? Now when you apply the limit cot pi by 2, sin pi by 2 is 1, so log 1 is 0, so it is of the form 0 by 0 form. So let us differentiate this. So limit x tending to pi by 2. Now we have log of cos x, right? Log of cos x, sorry, log of sin x. So it is 1 by sin x, d by dx of sin x is cos x. Log f of x is 1 by f of x into f dash of x. D by dx of cot x is, what is the area of cot x? It is minus cosecant square x. Minus cosecant square x. Now you will be left with, cos x by sin x, right? Cos x by sin x is 1 by sin x into cos x. Log 1 by sin x cos x. Okay. So let us simplify this to some more extent, right? So we have limit x tending to pi by 2 cos x by sin x. This 1 by cosecant square x can be written as sin square x, right? This 1 by cosecant square can be written as sin square x. So this 1 sin x will get cancelled. So you'll be left with minus cos x into sin x. When after the limit it is 0. So log y is 0. So you take e on both sides. So e power log y is e power 0. So y is equal to 1. E power 0 is 1, right? In any non-zero number, whole power 0 is 1. So y is equal to 1 is the required limit for this function. Okay. The fourth problem. Limit x tending to 0 sin x by x whole power 1 by x. Now we can see this sin x by x will tend to 1, right? Because sin f of x by f of x is 1. Provided your f of x is 0 as x tends to 0, here as x tends to a. So it is of the form 1 power infinity form. So let us call this as y. So y is equal to limit x tending to 0 sin x by x whole power 1 by x. Now you take log on both sides. So log y is equal to limit x tending to 0 log of sin x by cos x whole power 1 by x. This is limit x tending to 0 this is 1 by x into log of sin x by x, right? Is it clear? So it is 1 by x log of sin x by x. So how we will differentiate this? So in the numerator we have log of sin x by x. The denominator we have x, right? Okay. Now you differentiate this. So log f of x. So 1 by sin x by x, 1 by f of x into f dash into d by dx of f of x. Denominator will be 1, right? Because d by dx of x is 1. So log f of x, 1 by f of x into f dash of x. So this will become x by sin x. This will become x by sin x. So here we have limit x tending to 0. And d by dx of this, we need to apply quotient rule. So u by v. V into u dash minus u into v dash divided by v square. So let's keep x as it is. Sin x derivative is cos x minus, let's keep sin x as it is. Derivative of x is 1 whole divided by x square. Okay. Now let us try to apply the limit here, right? So we have limit x tending to 0, 1x will get cancelled. So we have limit x tending to 0, x cos x minus sin x whole divided by x cos x minus sin x whole divided by sin x, right? See, what I can do is, let us write this sin x as, let us multiply and divide by x. This will become 1. This x will also will get no. Let us keep this as it is. So we have x cos x minus sin x whole divided by, here we have 1x and here we have sin x, so it is x sin x, right? Now this is limit x tending to 0. Let us write this as x cos x minus x by x square, right? I'm just applying standard formulas. So I'm multiplying dividing by x. Here I'm multiplying dividing by x. Now you differentiate this. So limit x tending to 0. Let us keep x as it is. Derivative of cos x is minus sin x. Let us keep cos x as it is. Derivative of x is 1. And this derivative of x is 1. And this is 2x. When you apply the limit, it is of the form again 0 by 0 form. So limit x tending to 0. I can rewrite this as minus x square plus cos x minus 1 by 2x. So we have sin x here. Let us multiply and divide by x. So this will become 1. So again, it is of the form 0 by 0 form. So differentiate this. So this is minus 2x. Derivative of cos x is minus sin x. And this is 2. So when you apply the limit, it will be 0, right? It is 0 by 2, which is 0. So we have log y is equal to 0. So e power log y is equal to e power 0. So that means y is equal to 1 is the required limit for this function. Okay. Okay, I'm going to solve the last problem in this case. You are going to solve many problems after this. So limit x tending to 0, sin x whole power tan x. So it is of the form 0 power 0 power, what is tan 0? Tan 0 is sin 0 by cos 0. So it is of the form 0 power 0. So again, same technique, y is equal to limit x tending to 0, sin x whole power tan x. You take log on both sides. So log y is equal to limit x tending to 0, log of sin x whole power tan x. So this is limit x tending to 0, tan x of log of sin x, tan x of log of sin x. So this is limit x tending to 0, log of sin x whole divided by, what we can do is, let us write this tan x as cot x, right? Cot x. So again, it is 0 by 0 form. Sin 0 is 0. It is infinity by infinity form actually. So you differentiate this. So limit x tending to 0, log of sin x. So 1 by sin x into cos x. Cot x is minus cosecant square x. So we have limit x tending to 0. So cos x, so we have cos x by sin x. Let us keep this minus here. 1 by cosecant square x is sin square x. So we have, this is equal to 0, right? Because sin x into cos x, so 0 into 1. So we have log y is equal to 0. So that means y is equal to e power 0. That means y is equal to 1 is the required limit for this function. So this is the, I think you got idea about 0 power 0, 1.20, infinity power 0, right? Very simple. You just have to take log on both sides. Then it will be reduced to 0 by 0, infinity by infinity form. Just apply the previous concepts. Don't forget to take e on both sides because you're getting e log y limit. We need to find y. From that you take y, right? Okay. Now the last topic that can be asked in limit is, so the next type is, see, the question will be like, limit value is given, we need to find unknowns. We need to find unknowns, right? We need to find unknowns. This can be done in two ways. I'll teach you two ways, both the ways, but I suggest you the best way is using McLaren series. McLaren series we will discuss briefly in the upcoming lectures. But as of now, I'm going to write down the McLaren series formula, right? McLaren series expansions. This is just 11th standard, 12th standard level calculus. The expansion of e power x is 1 plus x by 1 factorial, x square by 2 factorial, x cube by 3 factorial, x power 4 by 4 factorial, and so on. And the expansion of sin x, x minus x cube by 3 factorial, x power 5 by 5 factorial, plus minus minus x power 7 by 7 factorial, and so on. And the expansion of cos x, 1 minus x square by 2 factorial, plus x power 4 by 4 factorial, minus x power 6 by 6 factorial, and so on. The expansion of log 1 plus x, and the expansion of log 1 minus x, and the expansion of tan x. So these are very basic expansion that you would know. So the next is log 1 plus x expansion, right? Log 1 plus x. So log 1 plus x is given by x minus x square by 2 plus x cube by 3 minus x power 4 by 4. Remember, factor will not come here, right? Okay. And then log 1 minus x is minus x square by 2 minus x cube by 3. See, these are the formulas. How it comes, I will explain in upcoming classes. As of now, you just remember formulas, right? So what McLaren series says is, if you have a continuous wave, any continuous function can be represented as a sum of infinite series. That's what McLaren series says, right? If you give me any continuous function, I can always write that as an infinite series of algebraic terms. That is very important, right? See, this is e power s exponential function, but I'm tracing this exponential function with the help of algebraic functions. You can see every terms in the series involves only algebraic functions. Algebraic function means x square, x cube, like that. So any continuous function, it can be exponential, it can be trigonometric, it can be logarithm, it can be anything. So what McLaren series says is, any continuous function f of x can be written in the series expansion as f of 0 plus f dash of 0 by 1 factorial into x plus f double dash of 0 by 2 factorial into x square plus f triple dash of 0 by 3 factorial into x cube. This goes on and on. When you put all these in this expansion, you will get all this expansion. This we will discuss more in the upcoming classes. Okay. This we will discuss more in the upcoming classes, right? Okay. Tan x, McLaren series expansion of tan x. So tan x is x plus x cube by 3 plus 2 by 15 x power 5 and so on, right? Okay. So with this, we can find, with this help of this, we can also find the unknowns. So we'll straight away get into the problem. We're going to do only some 4 to 5 problems, and then we're going to wind off this today's class. Okay. So problem 1. Find the values of a and b. Find the values of a and b. Okay. So find the values of a and b if limit x tending to 0, x into 1 plus a cos x minus b sin x whole divided by x cube may be equal to 1. May be equal to 1. You can see the limit value is given. We need to find the unknowns. That's what I said, right? Limit value is given. We need to find the unknowns in function, right? In the functions. So you can see it comes under this type. Okay, how to do this? I'll do it in two ways. So method one is using McLaren series. Using McLaren series. And then method two is I'll do this also using L'Hopital rule. Okay. So we have limit extending to 0, x plus a into x cos x minus b into sin x whole divided by x cube. I've just multiplied x inside. So we have this they have given this limit is equal to 1. So limit x tending to 0, x plus ax into, you just apply McLaren series for cos x. So it is 1 minus x squared by 2 factorial plus x power 4 by 4 factorial and so on, minus b into, you just apply the limit for a sin x. So x minus x cube by 3 factorial plus x power 5 by 5 factorial and so on, whole divided by, very, very important step. Sir, it is cos x in question. Whatever, is there any mistake I have made? See, here I have x and here I have ax cos x and here we have minus b sin x by x cube. Correct only, right? Whole divided by x cube and this is equal to 1. Is it clear up to now? I just applied McLaren series expansion for cos x and sin x. Now what I'm going to do is, you collect all constant term, you collect all x terms, you collect all x square terms, you collect all x cube terms. First, you collect all the constant terms. You don't have any constant term in this expansion, right? Here we have x, here although here we have 1, but if you multiply this ax inside, it will be not a constant term. Here also no constant term here. Now collect all the x terms coefficients. Here the x term coefficient is 1, here the x term coefficient is a, here the x term coefficient is minus b. Is it clear up to now? Is this step is clear? So I want everyone to chat in the comment section. So I'll go for next. Very, very important step. I'm just collecting all the constant term. I'm collecting all the x terms. So here the x term is 1. Here the x term coefficient is a. Here the x term coefficient is minus b. Okay. Now you collect all the x square term. Here there is no x square term. Here is there any x square term in this expansion? Is there any x square term in this expansion? No, because I have to multiply ax inside. If I multiply ax inside, there won't be x square term here. Is there any x square term here? Again, there is no x square term here. So x square term is 0. Now you collect all the x cube term. Is there any x cube term here? No. Is there any x cube term here? Yes. What is the coefficient? It is minus a by 2. Yes or no? Minus a by 2. Is there any x cube term coefficient here? Yes. It is plus b by 3 factorial. And I don't need any terms other than x cube. In the denominator, we have x cube. So I don't need any term other than x cube. You just put order of x power 4. Order of x power 4 means x power 4 term and degree higher term. This is equal to 1. Now you divide this separately. We have limit extending to 0, x into 1 plus a minus b whole divided by x cube plus x cube into minus a by 2 plus b by 6, 3 factorial is 6 whole divided by x cube. See, plus order of x power 4 plus order of x power 4 by x cube is equal to 1. Is this step is clear? I just expanded McLaren series and then I have collected all constant terms, degree 1 term, degree 2 term, degree 3 terms. Now this will be 0, right? Because here we have x power 4. If I cancel this, all the terms after this will be 0. Limit will be 0. That is why I put order of x power 4. Even if you have x power 5, x cube x power 5, x square will be numerator When you apply the limit x tending to 0, this term will be 0. Now this will be left with limit x tending to 0, 1 plus a minus b by x square, plus these two will get cancelled. So we have minus a by 2 plus b by 6 by 1 is equal to 1. Now, very important step, we are given this limit is equal to 1, right? When you apply the limit here, denominator is 0. So surely this number has to be 0. Yes or no? Surely this number has to be 0. Then only you will have, then only you will have a finite limit. Then we will have 0 by 0, it will be finite limit. Suppose if this number is non-zero, what will happen? Non-zero by 0, this will tend to infinity. But they have given the limit is finite limit. So surely for finite limit, 1 plus a minus b has to be 0. This number has to be 0. If this is non-zero, non-zero by 0 will be infinity. So this term will get vanished because this term is equal to 0 now. So this term has to be equal to limiting value. So minus a by 2 plus b by 6 has to be 1. So solve these two equations for a and b. Is it clear? Is it clear? I'll repeat. What I did is I've just collected all x terms, x square terms, x cube terms. Since the denominator is x cube, I don't need any term other than with you restrict from x cube. I don't need any term other than x power 4 above x power 4 or x power 4. Now you divide separately. So x cube will get cancelled. So this has to be 0 for finite limit, and this has to be equal to 1 because this is 0. So solve for a and b. So we have a minus b is minus 1. So cross multiply this. We have minus 6a plus 2b equal to 12. Right? Multiply 2 here. So we have 2a minus 2b is equal to minus 2. Minus 6a plus 2b is equal to 12. So we have minus 4a is equal to minus 10. That means a is equal to 10 by 4. So 10 by 4 is 5 by 2. So a has to be equal to 5 by 2. And we know 1 plus a minus b is 0. So b is equal to 1 plus a. So 1 plus 5 by 2. So which is b is equal to 7 by 2. So when a is 5 by 2 and b is 7 by 2, then this will happen. B is equal to 1 plus, okay, it is plus 10, sorry. Okay. So a is minus 5 by 2. So 2 minus 5. So b is minus 3 by 2. B is equal to minus 3 by 2. I'll do the same problem with the L'Hopital rule. Method 2 using L'Hopital rule. Okay. So let's take the same question. Limit x tending to 0, x into 1 plus a cos x minus b sin x whole divided by, I will do 4 to 5 questions, but I'll do the same question using L'Hopital rule. Whole divided by x cube is equal to 1. Okay, so this is limit x tending to 0, x plus ax cos x minus b sin x whole divided by x cube. See, when you apply the limit, it is of the form 0 by 0, right? So I can differentiate this. So we have limit x tending to 0, derivative of x is 1. You differentiate this, let us keep x as it is. Derivative of cos x is minus sin x. Let us keep cos x as it is. Derivative of x is 1 minus b cos x whole divided by whole divided by 3x square. Now, when you apply the limit, what happens? Denominator is 0. What happens to the numerator? We have this will be 0 when you apply the limit. This will be 1. So we have 1 plus a minus b. Is it clear? When you apply the limit, you will have 1 plus a minus b. Now, surely, numerator has to be 0. Then only it will be 0 by 0 form. Then only have finite limit. So surely, numerator has to be 0. So we have got the first equation here, right? This is the first equation, right? 1 plus a minus b equal to 0. We have got the same equation here also. I'm differentiating one time, applying the limit. Denominator is 0, so numerator has to be 0. If numerator is non-zero, limit will be infinity, because non-zero number divided by 0. But the limit is finite number, it is equal to 1. Okay, let us assume that 1 plus a minus b equal to 0. Then we will proceed. So we have limit x tending to 0, 1 minus ax sin x plus a cos x minus b cos x whole divided by 6x. Now again it is 0 by 0 form, right? When I apply the limit, it is of the form 1 plus a minus b. That has to be 0. I'm asking that is 0. So it will be 0 by 0 form. Now again you differentiate. This is 3x square. I'm not differentiating. You again differentiate to take so much of time in compared to this method. So differentiate, this will be 0. X sin x. So x into cos x plus sin x. Derivative of cos x is minus sin x. Derivative of cos x is minus sin x whole divided by 6x. Now when you apply the limit, it is of the form 0 by 0, right? Because 0 into cos 0, sin 0, everything is 0. So you have limit x tending to 0 minus ax cos x minus ax cos x minus a sin x. And here we have minus a sin x. And here minus a sin x. And here we have plus b sin x whole divided by 6x. So it is of the form 0 by 0. You differentiate. So limit x tending to 0. So minus a times derivative of x cos x. So x into minus sin x plus cos x. Right? Now, this is what I can do is, in this step, I can take sin x common, right? If I take sin x common, we have minus 2a plus b. So minus 2a plus b derivative of sin x is cos x whole divided by 6. See, here you are getting finite limit because your denominator is 0. So that means this limit has to be equal to 1, right? Because it is given that this limit is equal to 1. That means here getting finite limit, that limit has to be equal to 1. When you put x is equal to 0, this will be 0. This will be 0. So here we have, when you put 0, this will be 0. This will be cos 0 is 1. So minus a plus minus 2a plus b by 6 is equal to 1. So here we have minus 3a plus b is equal to 6. This is the same equation we got here, right? You divide by 2. Minus 3a plus b is equal to 6. This is what you got here. So solve from 1 and 2, you'll get the same value of a and b. Is it clear? Whichever is convenient for you, you can make note of it, right? Okay. See, if the denominator is 0, numerator has to be 0. From that, you got this equation. Here, when you apply the limit, it is 0 by 0 form. You differentiate this. If you are getting a finite limit, that finite limit has to be equal to the given limit, because the given limit is equal to 1. Okay. So I'll give you one exercise problem based on this. Find the value of values of A and B if limit x tending to 0, x into 1 minus a cos x, same question, plus b sin x whole divided by x cube may be equal to 1 by 3. So in the previous problem we have minus b here. So instead of minus b you have plus b and the limit is equal to 1 by 3. So you apply McLaren series directly. So in the group you can share your solutions. I will do the third problem now. You apply the McLaren series expansion. Here we have plus b and then equal to 1 by 3, not 1. Okay, problem 3. Find the value of I'll do by McLaren series, you do by L'Hopital rule in your own. Find the value of ABC so that limit x tending to 0, a into e power x minus b into cos x, c into e power minus x whole divided by x into sin x is equal to 2. Okay. Now here we have sin x. Let us multiply and divide by x. So the question is replaced as limit x tending to 0, a into e power x minus b into cos x plus c into e power minus x whole divided by x square is equal to 2. See, when you if you replace x is equal to e power minus x, you will get the expansion of e power minus x. So e power minus x is 1 minus x by 1 factorial plus x square by 2 factorial minus x cube by 3 factorial and so on. You just replace x by minus x. Okay. So we have limit x tending to 0, a into e power x 1 plus x by 1 factorial, x square by 2 factorial, x cube by 3 factorial and so on, b into cos x 1 minus x square by 2 factorial, x power 4 by 4 factorial and so on, e power minus x 1 minus x by 1 factorial plus x square by 2 factorial minus x cube by 3 factorial and so on, whole divided by x square and that is equal to 2. Now you collect all the constant terms. What are the constant terms you will have? Here you will have a, here you will have a, and here you will have minus b, and here you will have plus c. Now you collect all the x terms. Here you will have a, here there is no x terms, here the x term is minus c. Is it clear? I'm just collecting all the like terms. Now you collect all the x square terms. Here the x square term is a by 2. Here the x square term is plus b by 2. Here the x square term is plus c by 2. I don't need any terms other than this because the denominator is x square. I'll just put order of x cube whole divided by x square, and we know this limit is equal to 2. Now divide separately. So limit x tending to 0, a minus b plus c whole divided by x square, x into a minus c divided by x square plus x square into a plus b plus c by 2 whole divided by x square. This is equal to 2. Right? Now, what is the conclusion here? A minus b plus c has to be 0. Right? If it is 0 only, it will be finite limit. If it is non-zero means non-zero by 0, it will tend to infinity. But the limit is 2. So for a finite limit, this has to be 0. For a finite limit, this has to be 0. And similarly, this also has to be 0. A minus c has to be 0. If this a minus c is not 0, then we have something by x. Again, it will tend to infinity when x is 0. So this term fully will be 0. This term fully will be 0 with the assumption that these two happens. So this number has to be equal to the limit value. So a plus b plus c by 2 has to be equal to 2. So solve for ABC from these three equations. So we have a minus c is equal to 0, a plus b plus c is equal to 4. So solve for ABC. Is it clear, everyone? Is the McLaren series method is clear? Very simple. You collect all constant term, x square term, x cube term. All the terms that has denominator, if it is variable, numerator has to be 0, numerator has to be 0. You mark all the equations. The term which is equal degree has to be equal to limiting value. After that, everything will be 0. Okay, so from this we have a is equal to c. So from 1, since a is equal to c, we have 2a minus b is equal to 0. And from 3, since a is equal to c, we have 2a plus b is equal to 4. So we have 4a is equal to 4, a is equal to 1. So if a is equal to 1, what about b? B is equal to 2 times a. So 2 times 1. So this implies b is equal to 2. A is c is equal. So a has to be equal to 1. Therefore, a is equal to 1, b is equal to 2, c is equal to 1 is the required value of a, b, and c. Okay. The last problem that you're going to do, okay. You can try L'Hopital rule. In the book they have did in L'Hopital rule. In the book they have did in L'Hopital rule. I said materials. If you want to do in L'Hopital rule, follow that book. Right. So problem 4. If limit extending to 0. Yesterday itself I sent that book, right? In the book itself, there are 4 problems in this method. There they have did using L'Hopital rule. Divided by x cube is finite. Find the is finite. They are given it is finite. Find the value of a and also find the limit. Okay. Solution. So we have limit extending to 0, sine 2x plus a sine x whole divided by x cube. See, sine 2x expansion. We know sine x expansion is x minus x cube by 3 factorial plus x power 5 by 5 factorial and so on. So sine 2x. So limit extending to 0, sine 2x. 2x minus 2x cube whole cube by 3 factorial, 2x whole power 5 by 5 factorial and so on, plus a into sine x, x minus x cube by 3 factorial, x power 5 by 5 factorial and so on, whole divided by x cube. We don't know it is equal to, but it is equal to some finite number. So limit extending to 0, there is no constant term. Now collect all the x terms. What do you have? If you collect all the x terms, it is 2 plus a. Now you collect all the x square term. There is no x square term. You collect all x cube terms. Here x cube term is what? Minus 8 by 6, right? Minus 8 by 6. A2 cube is 8. 3 factorial is 6. Minus 8 by 6. Here the x cube term is minus a by 6. Minus a by 6. Plus here we have x power 5 terms that we don't need, whole divided by x cube. When you divide separately, you will have x into 2 plus a by x cube into minus 8 by 6 minus a by 6 whole divided by x cube. Here we have order of x power 5 by x cube, and this will be 0. Because when you cancel this, you will have x square in the numerator. When you apply the limit, it will be 0. So that means 2 plus a has to be equal to 0. 2 plus a has to be 0. That means a has to be equal to minus 2. If a is minus 2, this full term will be equal to 0. And all these terms after this are 0. So this term has to be the limiting value because these will get cancelled. So limit value is minus 8 by 6 minus a by 6. So minus 8 by 6, and we know a is minus 2, so it is plus 2 by 6. So minus 8 plus 2, so minus 6 by 6. So the limit is minus 1. The limit is minus 1, and the a value is minus 2, right? And the a value is minus 2. So you can see in the book they have did everything using a L'Hopital rule. So these are the 4 problems that I have discussed. So you can see that find the value of a and b in order that limit is equal to 1. They have did using L'Hopital rule, right? You can do in anything, but I've did in McLaren series because I'm more comfortable with McLaren series. So find the value of ABC so that this is equal to 2. They are using L'Hopital rule. See, we have got the same equation, right? A plus b plus c is equal to 4. And then we have a minus c is equal to 0. A minus b plus c is equal to 0. But the same they got using L'Hopital rule. And here also find the limit be finite, find the value of a and the limit. So here it turns out to be minus 1, but they did using L'Hopital rule. So I completed the task. I completed what I want to take in this class. So after this session, what you do is these 4 problems you do using L'Hopital rule, and I think you would have finished these types 0 and infinity, infinity minus infinity. Now you just start doing this type, the form 0 power 0, 1 power infinity, infinity power 0. So there are some, I think there are some 25 to 30 problems. Yes, there are some 28 problems. I have solved some 5 to 6 problems. Same technique you have to do. So take log on both sides. You take log on both sides. It will be reduced to 0 by 0 infinity by infinity form, and raise e on both sides to get the limit, right? So that's it. So the next class we will do the next topic, right? Okay. So thank you. Bye.